Hello learners, welcome back. Previously, in lesson 3, we were dealing with the periodic table. In lesson 4 here, we are dealing with the relative atomic mass, which we can say R.A.M. So what is relative atomic mass? Relative atomic mass is the average mass of an atom of an element, of the element, compared with the 1 out of 12 of the mass of one atom of carbon-12. So if you are told to define relative atomic mass, you define us like that. So mass is spectrum. A spectrometer is the instrument used to determine the relative atomic mass of elements. So the relative atomic mass of an element is closest in value to the mass of the most abundant isotope of the element. So the most abundant means if you are dealing with percentage composition and maybe an isotope of the element is having a percentage of maybe 70 with maybe mass number of 16, and we're having another one having an isotope with mass number of maybe 18 but having a percentage abundance of 30, it means the relative atomic mass will be closer with the one that's having a higher percentage. That means the answer will be 16 point something, not close to 17 point or 18 point something, because the one that's having the most abundance will be closer to the relative atomic mass. Okay, let's go the first one, calculating the relative atomic mass itself. So, example, we are told chlorine 35 forms 75% of the total mass of chlorine, and chlorine 37 forms 25%. Calculate the relative atomic mass of chlorine. So we are having a formula. If you want to get relative atomic mass, the formula is you are supposed to have mass number one times, if you are given percentage number 1 over 100, then plus mass number 2, which is the second isotope, multiplied by the percentage number 2, then divided by 100. That's the formula that you are going to do if you are given percentage abundance. So check this question. You are told chlorine dash 35. So this means it doesn't mean negative 35. This dash is only for to differentiate or to give you that 35 is the mass number. Remember, mass number cannot be negative. Okay, R.A.M. will be equal to mass number, which is 35, times percentage, which is 75, divided by 100, plus mass number 2, which is 37, times 25, which is percentage composition, percentage divided by 100. So using the calculator, what are you going to get? 35 times 75 divided by 100. There, we are going to get 26.25. Plus, what about on the other side? 37 times 25 divided by 100. So here you are getting 9.25. When you add 26.25 plus 9.25, you are going to get 35.5. So 35.5 is the relative atomic mass of that chlorine. So learners, you can know your answer whether you are correct or not by checking the most abundant. So the one that's most abundant is this one, isotope chlorine 35. So that means the answer must be close to 35 point. So it's 35.5. And remember, relative atomic mass has no unit. So you cannot put anything in front of this 35.5. Let's go to number 2. Number 2, we are having determining the relative atomic mass, that's R.A.M. of an isotope of element C, with the following mass numbers and relative abundance. So we are having 3 mass number. The formula will be mass number 1 times percentage number 1, because they have given us percentage abundance, divided by 100, plus mass number 2 multiplied by percentage number 2 divided by 100, plus mass number 3 multiplied by percentage number 3 divided by 100. So what are we going to get as mass number 1? 39 times 83.1 over 100, plus mass number 2, which is 40, times 0.01 divided by 100, plus mass number 3, which is 41, times 16.89 divided by 100. Okay, learners, the reason why we are taking 100 is that when you add all this percentage, they will become 100. So 39 times 83.1 divided by 100, we are going to get 32.409, plus we are having 40 times 0.0 times 0.01 divided by 100, which is 0.004 plus 41 times 16.89 divided by 100. Here we are having 6.9249. So let's add all of them. 0.004 plus 32.409. We are getting R.A.M as 39.3379. There's no unit for R.A.M. You can confirm whether you are correct or not by checking the most abundant. So it's 83.1. That's the percentage. So check the mass number. It's 39. So the answer will be 39 point something, 3379. So you are correct like that. Okay, let's go to example 3. In example 3, we are given element K has two isotopes with masses 16 and 18 in the ratio of 1:3 respectively. Determine the R.A.M of X. So here we are given the ratio form. So we have not been given percentage. So the formula will be just very simple. You say R.A.M is gotten by mass number 1 times ratio 1 divided by the total ratio. That's TR is the total ratio. You add plus mass number 2 multiplied by ratio 2 divided by the total ratio. So here we are having 1:2. What is the total ratio? It will be 1 plus 3. Those are 4. The total ratio is 4. Okay. So let's see. Mass number 1 here is 16 times ratio 1 is 1 divided by the total ratio, which is 4. Plus mass number 2 here is 18 multiplied by ratio number 2, that's 3, divided by the total ratio, which is 4. So what are we going to get here? So we're having 16 divided by 4, that's just 4. Plus, so here 18 times 3 divided by 4, we are going to get 13.5. 13.5. So if you add, you are going to get 17.5. So learners, again, you can know whether your answer is correct or not by just checking now the two isotopes, the two mass number. Then you check now the one that's having a higher ratio. The one that's having a higher ratio 3 is that 18. So the answer must be close to that 18. So 17.5 is closer when you compare with 16. So your answer is correct. Let's go next to example 4. We are told an element B consists of 3 out of 4. This is 3 out of 4 of X. That one is the mass number. Remember, we are told you can write atomic number and mass number in a format by putting the mass number on top, like 12, then the atomic number you're supposed to put down here. So this is mass number of 12. 3 out of 4 of X with a mass number of 12 and 1 out of 4 of X with mass number of 14. So calculate the relative atomic mass of element B. Okay, here you have been given fraction instead of percentage and also ratios. What you are going to do, the formula is just the same. You are dealing with mass number 1, R.A.M is given by mass number 1 multiplied by the first fraction, fraction 1, divided by the total fraction, plus mass number 2 multiplied by fraction number 2 divided by total fraction. So what's your mass number 1? It's 12 times the first fraction, that's 3 out of 4, divided by the total fraction. So what is 3 out of 4 plus 1 out of 4? These are 4 out of 4, which is just 1. So you say divided by 1, plus. Okay, mass number 2 is 14. So 14 times, we are going to say 1 out of 4, divided by 1, which is the total. Okay, what are we going to get there? So we're having 12 times 3 out of 4. 3 out of 4 equal to, so here we are having 9 plus, what about here? 14 times 1 out of 4. So we're having 3.5. So if you add this, we are going to get 12.5. 12.5. So remember, relative atomic mass has no unit. So learners, again, you can still know the answer where it is, if it's correct or not. You check now the one that's having a higher fraction. 1 out of 4 and 3 out of 4. 3 out of 4 is bigger. So the answer must be close to or near to 12. So it is 12.5. So we are very correct. So thereafter, learners, we are having the extended question. So you are supposed to attempt this question and try to write or share your response or answers in the comment section. So now let's meet on our next class as we look on the calculating the percentage abundance if you are given the relative atomic mass. That's Romeo 2. Because now we are given the percentage abundance, we were looking the relative atomic mass. In our next class, we are calculating the percentage abundance when we are given the relative atomic mass itself. Thank you. Welcome.